Now I'm ashamed. This is exactly what happened. I think I measured a charged capacitor, and now the tester will not turn on. At first I thought it was low on charge, but it's not a battery issue since it's charging and it's taking some charge, some current, 0.67. We can see we have two different power supplies because of the two different coils and the two ICs. One must be the charging power supply, so it takes the 5 volts from the USB and converts it to 3.7 volts to charge the cell. The other power supply must be the boost converter, so it steps up the 3.7 volts to measure or test Zener diodes. An LED for charging, it must be a 2-in-1. It lights up red for charging and green to show it's fully charged. And these are the resistors and the transistors to switch the LEDs on. When it's charging, there will be some current through these resistors, and that will form some voltage drop on the resistors. So that voltage will be used to turn on a transistor, and that transistor will switch or turn on an LED, the charging red LED. And this is the voltage regulator, right? Because I can see a trace going to this connector and to this diode. So this must be stepping down the 3.7 volts from the battery to 1.2 or 1.5 volts to power this IC or controller. Then you have this diode, which does not make sense to me. So we have a trace going to the negative of this connector. So this must be a reverse polarity protection. I don't understand because the battery is sealed inside and there is no way you can mistakenly put the connector in the wrong direction. The main controller and the crystal oscillator. Then a bunch of resistors and capacitors around the controller. This must be for filtering and protection for the signals going in and out of the controller. The connector, and on the back you can see the pins, and most of the traces end up in the controller. So if I send high voltage straight to that controller, I must say I'm not feeling very lucky.